Hello everyone and welcome back to another video. In this video I'll be going over palindrome pairs. So this problem gives you a list of unique words. It's important that they're unique. I'll get into that later. But you're given a list of unique words and you're supposed to find all the combinations of two words that you can use in the given list such that when you concatenate them it's a palindrome. So looking at their example, it's easy to see that when you concatenate this and this, so the word at index 0 and 1, you'll get a palindrome. Same thing if you do it the other way around. So if you concatenate this and this, it'll be A, B, C, D, D, C, B, A. So that's one palindrome you can get. The other way around just gives you D, C, B, A, A, B, C, D, which is a different palindrome that you can get. So there are these two. And yeah, so and a couple more examples. You could put this one first and this one second, and you'd get a palindrome. That's where this 3, 2 comes from. And you want to find distinct indices, so no concatenating a word to itself. So that's about it on the problem. I think it's fairly straightforward. So let's get into the solution. So a naive brute force implementation would actually just be to use two for loops to generate all the distinct indices in the given list, and check if concatenating them will give you a palindrome. However, if you look at these constraints, a good way to tell the runtime of a problem is to look at its constraints. And I actually misestimated like the runtime of this, because I saw that words.length is at most 5,000. So I actually tried the brute force solution at first. But if you think about it a little more, we'll need to use, it'll be generating all the distinct indices will be an n squared operation with two for loops. So that's 5,000 squared. And checking if a word is a palindrome is simply an O of n operation, where n is the length of the word. But because each word can be up to 300 letters long, we could have an n squared here, so that's 5,000 squared, multiplied by another 600, right? Because concatenating two words of length 300 would result in a 600. And if we do the math there, so 5,000 squared times another 600 inside, that actually goes much over. This number is far too large of a, like, it's going to be far too large, and it's not going to run within time constraint. But I actually thought originally, if it's 5,000 squared, it could have a shot of finishing. And just to prove that, my first submission using the brute force method actually TLE'd, obviously, and although it passed all the test cases, as you can see, with these two for loops generating the indexes, it simply exceeds the time constraints. So yeah, so I'm sorry if that was you wanted me to jump right into the explanation of the solution, but I thought it was pretty useful to be able to learn how to look at the constraints to figure out the runtime of a problem, because it's really useful in competitions. But yeah, so now let's get into the actual solution. Now that we know the brute force method won't work. So what we can actually do is we can, for every word that we look at, we can actually generate the strings that would be able to attach to the word to make a palindrome. So what do I mean by that? So let's just say we have this this string here. So we know we want to look for, so let's just first pretend that this string is the first one inside of our concatenation. So we know we want to look for, obviously, the reverse of the string, so D, C, B, A, because concatenating this and this would be a palindrome. But we also know that concatenating CBA would be a palindrome as well, because D is palindromic. So if you concatenate CBA onto it, you get A, B, C, D, CBA, which is also a palindrome. And we can essentially just loop through the word, and whenever this section here is a palindrome, we know we can attach the reverse of this to create a palindrome. So just to explain what I mean, we'll look at another example. So let's just come up with a random word here. So like A, B, C, D, C or something. So first of all, we know we can attach the reverse of this word because, yeah. And we know if we check this, this is a palindrome because C is just a single letter, and that's a palindrome. So we can attach the reverse of this. So then we go on. We check if this is a palindrome. It's not, so we know we can't attach the reverse of this. It won't work. But if we look at this, we see that this is a palindrome, so we can attach the reverse of this. So obviously attaching BA would make a palindrome. And you can start to have the intuition of how this works. So that's how we generate these strings that we can attach when this is the first word. And yeah, I should probably explain. It's useful to be able to generate these because we can use a hash map to know what strings are in our list, so we can instantly tell if we should concatenate this word with something, another word in our list to make a palindrome. And similarly to generating these strings that we need to attach, when this word is the first and we want to add another string after it, we can also pretend like it's the second. So we just need to use a slightly different logic here. So let's just say we have A, B, C, D again. So when it's the second, we know we want to add something to it when it's the reverse of this. So that'd be D, sorry, that'd be A, B, C, D here. So like the reverse order. So instead of A, B, C, D, it's D, C, B, A. So if you attach this, this would work. And remember how before we went through like this from the back. So we first checked if this is a palindrome, then this, and if they were, we'd attach the reverse of this to make a palindrome, like BA. This, instead of going from the back forward to check if this is a palindrome, we go from the front to the back and check if this is a palindrome and this is a palindrome. And we just simply do this because when pretending like this is the word in the second word in the concatenation, we just flip the logic. So we would, so for example, on this ABCD, we would first obviously know that reversing this entire thing would work, and then we check this. If this is a palindrome, then we know we can attach the reverse of this. And since a single letter is a palindrome, we know we can attach the reverse of BCD, so that's DCB. And as you can see, DCB ABCD is a palindrome. And so you would then just go from the back to the front like this. So you check if this is a palindrome, and if it is, you know you can attach the reverse of this. So using this method, we can essentially generate the strings we want to find, because let's say we have a list of strings here. So this is a list of strings, and we can put these all into a set, like a hash set or something, and we can essentially say, yeah, so this is a palindrome. We know we can attach the reverse of this, so we can look in our set here, and if we know there's another string CD that occurs in our list, we can basically we know that we'll have an entry like this 0, 1, where the first index will be since we're looking to concatenate this as a second, the index of this string here will be the second number in our array, like in our answer, and the index of this, we can just map it to the index. So let's just say CD is at the first index 1. Well, actually, we're pretending this is index 1, right? So because they're unique, let's pretend this is index 0. We know we can pair index 0 and index 1, and that would make CD and this string here. And obviously, this example doesn't work because when you AB is not a palindrome, but you know what I mean, right? Like if this was BB, BB is a palindrome, so then you could get CB, CD, BB, CD, and that's what you would get when you add CD in the front and AB in the back. BB, CD in the back. So now that we know how the solution works, let's look at how we implement this. So first of all, because we know the words in the list are unique, we can just shove them all into a hash map here, where the key is the word, and this integer will represent the index of that word. So because we want to find the index of the word that we want to pair it with. So we'll just loop through the words and put that word and its index inside of our map. Next, we'll create our answer that we need to return, this list of lists, essentially. And we'll want to keep track of the pairs that we've created to avoid double counting them. So we will essentially go through each word inside of our list, which is what this for loop does. And this for loop here will essentially generate the potential strings we can match it with. So this first bit of logic here pretends like our current word is the first word in the concatenation. So what we will do is we will do the method we described earlier, where let's just say this is the first word. We will go from the back to the front and check if whatever interval this is here, if this string here is a palindrome, then we know we are looking for the reverse of this. So we will go from the back to the front here. So the front to that current index. So this will loop through all the indexes in that word. So it'll start from here, then go to here, etc. And we'll substring that from that to the index. So that'll give us this segment here. And we'll reverse it. And then we'll check if the rest of the word is a palindrome. So I just have a method here that takes in a string and 2 indexes, and it checks if the whatever is in between these 2 indexes of the string is a palindrome. So I'll essentially pass in, hey, this is the index we want to start at. We want to go all the way up to this index, and we'll check if this little thing here is a palindrome. And if it is, obviously, we'll want to look for the reverse of this to attach. So something like that. So if it's a palindrome, I'll go over this method later. So just know that this checks if that segment of the string is a palindrome. So if it's a palindrome and we have a word in here that we can pair it with, so the reverse of it, of this little substring here, then we know we can pair the 2 words. So we essentially will, I have a method called make list, but essentially we'll pair the word at index I and whatever index this word is here. So we will make a list with index I, because this word will be the first one, and we will get the index of this word here. And this if statement here just prevents us from double counting or adding a word that's the same as itself, because we want distinct indices. So this check here just makes sure we get a distinct indice, because I is the index of our current word, and this is the index of the word we want to attach. We want to make sure they are different. And this just makes sure that we have not added this pair of indexes before. So if this area inside of our Boolean array is false, that means we have not added this pair, like I and this number. Then we know we should add that. So we'll add those two indexes and set that to true, so we don't double count and add those indexes twice. Then we do the same logic, but treating it as the second word. So instead of looking to see if from the back to see if this is a palindrome, and then reversing the front segment, we will check if the front segment is a palindrome and reverse the back segment. So here, since we're iterating through like the indexes in the string, we will find this back segment, which we will get in the substring here by substring at starting from that index, and reverse it. And then we'll check if this segment in the front here is a palindrome. So we'll pass in the word and this segment in the front, because we start from 0 and end at j. So we'll check if this is a palindrome and see if we can attach the reverse of this to the front. So we can attach a string to the front here. So if that's a palindrome and we find that we can actually attach this string here, which is the reverse to the front, then we will, this if check is the same logic as this. Then we will make a list with this as the first number and this is the second, because if you remember here, we want to concatenate our words by using this word as the first. So words I will be the first word in palindrome. So we want it to be in front of this other word. But in the other combination, we want it to be the second word. So we'll use it as the second number in the list. And we'll just obviously set a marker to indicate that it's true. And this way, we essentially will only need to iterate through the words array a single time. So instead of that O of n squared type of runtime, we will get this for loop here will be O of n, and generating these strings and checking if they are a palindrome are both O of n operations. So we, instead of having that 5,000, instead of having the 5,000 times 5,000 squared, instead of having that, let me just move this. Instead of having a 5,000 squared times 600 type of runtime, or 300, we can just simplify it. We'll have a 5,000 times 300, and we might have like a constant factor like 2, but it doesn't really matter. So essentially, we're eliminating this n squared in our runtime, because we won't have nested for loops that go through the entirety of word.length. And this for loop will only go through the length of that word. So that's 300. So we'll get that 5,000 times 300, and we avoid this 5,000 squared. So yeah, so if we look at these methods, these are just fairly standard methods. So we'll start from the simple ones. So make list just makes a list given two integers and adds them and returns that list. So that way I can just add make list and put these numbers in. And this just reverses a string, which is pretty self-explanatory. And this just checks if a string is a palindrome, if that segment of a string is a palindrome. So we have a start and an end. So This is essentially the bulk of our method here. So essentially, what we have is we have a string here. Let's just say A, C, B, C, A, and if our start and end are here, then we check if they are equal. If they are equal, we decrement end and we increment start. So then start will be here, and since we decremented end will be here. We check if they're equal, and while end is greater than start. Once we go here, we know start and end point on the same value, so end is not greater than start, so we can just return true because all of our checks worked out. So that's pretty much what we do. If they're not equal, we return false, otherwise we just decrement it, and when start is equal to end, we'll return true. And the reason why we have this check here, well, this part is just self-explanatory. We just need if start and end with the same value, we can just return true, since one character is palindromic. And I decrement end here because when I check if this is palindromic, I essentially treat it like the substring method. So if you don't know, substring works like this. So if you have a string like A, B, C, and you want to substring from index 0 to index, let's say 2, that will actually, this is index 0, 1, 2, that isn't inclusive of 2. So you'll actually get A, B as your substring, and to get A, B, C as a substring, you need to pass in 3, because 3, you'll get all the characters up to index 3. So I just have that same logic here. So you could probably, you could definitely do it another way, but yeah, I just have that logic where we want to pass in where we start and up to where we end. So if our ending index is 3, we will just check this string from 0, 1, 2, and this just makes my life a little easier because we will also use the substring method, and that way it's just we can use consistent indices for both using the substring and checking the palindrome. So yeah, so let's just submit this to show that it works, and it's accepted. It is a little bit messy because of all this. The logic is a little bit complicated to implement, but yeah, so that's how you can narrow down the runtime from the n squared to just 5,000 times 300 here. And yeah, so that's the end of this video. I hope you enjoyed, and thank you very much for watching.